As we mentioned in our earlier video, Cartesian product usually is not very meaningful. It will create a huge table and then create all kinds of combinations for the two tables that try to combine together. So in order to make it sense out of it, we need to add a where condition to provide the conditions that filter out everything that's not meaningful to us and only pick up the important information that we need. So let's take a look of the examples that we're going to see and consider that as a join operation. Take a look of this question. So saying that I want to find the name of the employee who has dependents. So who have dependent? If we only look into the dependent table, we can find out that these are the people who have dependents. So the social security number 333445555, 987654321, as well as 123456789. Those are the people who has dependents. So we need to find the name of these people. And therefore, we need to join the two tables together, finding out who are the ESSN equals to 333445555, which we, of course we know is Franklin Wong. As human, we can reference that, but we need the computers to help us doing so. So how do we do that? We actually want to join the two tables together through Cartesian product, this table with this table, and end up with a huge table. While in that huge table, we only pick up the things that we are interested in, which means that the social security number equals to ESSN over here. Let's take a look at this. While we try to do Cartesian product the two tables, you can see that we are able to use the front part Cartesian product the two tables, and then the condition is that SSN equal to ESSN. I want you guys to think about this. When we try to do the Cartesian product of these two tables, first of all, we will end up with a table with all of these 10 attributes plus these 5 attributes. So the huge table will be 15 attributes. The number of tuples in that newly created table will be 8 multiplied 7, end up with 56 tuples. So for the first one, the employee, for every employee, it will append the first dependent. And then the next 8 tuples would be all of these 8 employees append this second tuples in back of it. So we're only interested in the ones that have the same social security numbers that match with each other, so that we will end up with, by adding this condition, we will end up with only these 7 tuples that satisfies the condition. So we can know by looking into this table, and we only select out of 15 attributes, we only want to see the name of that. We will be able to see that these are the 7 employees. So we find the name. These are the 7 tuples that have the same informations, matching the ESSN with SSN. So if we can see that if we try to run this code in our table. So let me see. Go down over here. When we try to run the code, okay, there are some problems over here. Okay, so you can see that we will be able to get all of these 7 tuples, finding out who are the employees that have dependents. Of course, you may have one curiosity saying that, wait. I see there are 7 tuples, but there's actually 3 employees. How can I get only those 3 employees? I don't need to see John Smith for 3 times as well as Franklin Wong for 3 times. So that in Oracle, there's one reserved word called distinct. It's the keyword for you to find the non-duplicate tuples. That matches actually the theory of the database, because you don't want to see 2 tuples that are exactly the same with each other. So this is like the keyword or the important things for you to use if you're only interested in the employees with no redundancy. So you can see that by adding, the code is exactly the same. The only difference is that we add a distinct over here, indicating that I don't want to see the duplications. And this can answer the questions perfectly over here. So if we move on a little bit further, saying that find the name of the employee who has dependent. Now we have the same questions by adding one more condition, saying that I am only interested in female employees. So by doing so, basically we don't need to change much. After the where condition that we join the two tables, we just add the sex equals to female. However, you can see that instead of using sex equal to f, I actually use the object-oriented concept, indicating that I am talking about the sex attribute in employee. Why do I need to do that? That requires us to take a look back to the original data. So you can see that in the employee, it has a sex attribute. However, the dependent also have a sex attribute. So basically, the two attributes are using the same name. Therefore, I want you guys to see this. If I'm trying to do, instead of using employee.sex, which is very clear, indicating that the sex attribute coming from an employee, if I don't do that, I want you guys to see this. If I don't do that, and I simply say sex equals to f, and then hit a semicolon over here, the computer will not be able to know which sex attribute I'm talking about. I'm talking about the employee sex attribute, or I'm talking about a dependent sex attribute. So you will see this warning information, say ambiguity. Then you will not be able to retrieve the information. And therefore, what we need to do is using the object-oriented concept over here, indicating which tables, which attribute. This only requires when the attributes are duplicated in more than one table. So in this case, we can use this method to give very clear instructions of which attributes that we are talking about. So this is how we are able to do the join operation by providing the information that comes from two tables. So this for the join operation, you can see that this is a Cartesian product plus a where condition. So you add a condition after the Cartesian product. In this case, you still end up with n plus m attributes from the two tables, which means that the n table is from the first table, the m attributes is from the second table. So the new table you generated still have this large amount of attributes. However, the number of tuples that you will have is going to be less because you add a where condition, so you filter out many other things. This is usually the general format of the join operation, which we call a equal join. So what they're trying to say is generally still using the select and from where. You select the columns that you are interested, and then you provide the number of tables. So you can see that it's plural over here, indicating you can put two or more tables to form the Cartesian product, and then you provide the join condition. When we are talking about the equal join, that's indicating the join conditions we provide are usually equal, such as ESSN equal to SSN, this kind of what we call the equal join. So equal join can be look into another example. And now I want you guys to see this. In the previous class, I gave you an assignment with this one. Find the name of employees who work for department number 5. So you can see that for this question, it's actually super easy. If we simply look into the employee table, we know there is a department number over here. So because the employee works for department number 5, you can simply doing select first name, last name from employee table where DNO equals to 5, because you do have that information in the employee table. However, I want you to compare the second query over here. Find out the name of the employee who works for research department. This is very different from the previous one because if you look into the employee table itself, there is no research showing anywhere in the employee table. So you are not able to simply look into the employee table and then be able to apply the research over here. Therefore, you need to join the tables of employee with the department and using the research word in here, the name, to filter out the information you need. And that's why we need to join the two tables together. You may have a curiosity. How do I know if I'm going to join the two tables, saying the employee and department? How do I know the join conditions? This is when we need to reference back to the relational schema diagram. Remember the foreign keys. This is where we link everything together. DNO has a foreign key goes to D number. That's what we are using as the equal sign over there. The same thing is, remember ESSN from dependent equals to SSN because we did form a foreign key indicating the two attributes are the same in winning the same domain, and therefore we are able to reference each other. So we can see that when we try to join the two tables, finding out the questions that we have, we can simply select start, which means we find all the things that we have from employee and department. So we can Cartesian product the two tables together and then where DNO equals to D number. So you can see that when we try to run this code over the Oracle, it will show you that there are 8 rows selected. And now everyone, okay, take a look of this one. James Borg, he have all the informations that you need. And it says that it works for department number 1. Originally in the employee table, it ends over here. But now since I joined the two tables together, I have more information indicating he works for headquarters and then headquarters department number 1. The manager is this social security number, and then the start date is this one. So all the information are linked together. And therefore, if we want to find the people who work for research department, then all we need to do is add one more condition. The name equals to research. And so you can see that we still have the select from and where. That's the same thing. Now we add one more condition. The name equal to research. We will be able to retrieve the people who work for the research department. And therefore, this is how we will be able to see. Sometimes you can see that if I'm going to copy and paste the codes that I have wrote in the Word or PowerPoint, you will see some error messages indicating the quote is not correct. So this is something I want to show you one more time. If you pay close attention on the quote on research, I'm going to delete that and I'm going to write a single quote in the Oracle. You can see the comparison of this one and this one are actually different. They have actually different font or different style they provide. So you need to modify that, hit a semicolon, then we will be able to find out the informations. So their first name and from department equal to research. Okay. So that's actually pretty interesting. Okay, so you see there's one more kind of mistakes over here. I want to show you that when I'm copy and paste all of those things, the quote is different now. I believe the research over here need to be capitalized. And this is another example I want to show you the difference. Oracle itself is not case sensitive. However, the information or the tuples stored in the database do care about the case. So you can see that now what I'm trying to change is that I'm trying to change that into the it's actually pretty difficult to make it work over here. So that if we try to make sure that the quote is going to run correctly, this shows me a quote problem again. So I need to go back over here, finish that quote, put a semicolon, and you can see that the research that I put has to be a capital R over here. So let me copy and paste this code so that I'm not going to have the problems over here. So you can see that when we are doing that, the quote over here is again using the formats over here.